I'm Shital Adamile, and this is my teammate Samiksha Uddhav Wagmare uh, from Electronics and Telecommunication Engineering Department. Today we are going to present our internship on electric vehicles and Advanced Driver Assistance System ADAS completed at EMERTXE Information Technology. So, about the About the internship. This internship was conducted for 1 month in online mode. The main domain of this internship was electric vehicles and ADAS. The primary objective was to understand embedded system and how they are used in electric vehicles. The important learning areas included STM32 blue pill microcontroller, sensors, analog to digital converter ADC, timers, electric vehicle technology, advanced driver assistance systems. This internship combined both theory and practical implementation, helping me improve my programming and embedded system skills. So, next is STM32 blue pill. This slide explains the STM32 Blue Pill development board. The STM32 Blue Pill is a low-cost development board based on the STM32 F01033C86 microcontroller. It contains a 32-bit ARM Cortex-M3 processor, which is faster and more powerful than my traditional microcontrollers. It supports several peripherals such as GPIO, ADC, timers, UART, SPI, I2C. These peripherals allow the microcontroller to communicate with external devices and sensors. During the internship, I learned the architecture of STM32 Blue Pill and created project using STM32 Cube IDE. I configured GPIO pins to blink an LED, generated executable files, and tested the program using simulation software. The STM32 Blue Pill is widely used in robotics, IoT, industrial automation, automotive electronics, and embedded systems because it provides high performance at a low cost. So next is STM32 Cube IDE. This slide explains STM32 Cube IDE software. STM32 Cube IDE is the official software provided by STM uh, microelectronics for developing STM32 application. It combines coding and editing, compiling, debugging, and programming into a single software. In STM32 Cube IDE, we can create a new project, configure GPIO pins, means general purpose input output pins, configure timers, configure ADC, generate initialization code, write C programs, build and compile program, debug errors, upload program into STM32 boards. During the internship, I learned how to create a STM32 project, configure peripherals, write embedded C code, compile the project successfully, and debug errors. This software makes embedded programming much easier. So next is LED toggling in PICSimLab. This slide explains how my first practical experiment. The objective was to blink or toggle the LED. LED blinking is considered the first step in embedded programming because it is verified that the microcontroller is working correctly. During this experiment, I learned how GPIO pins works, means how general purpose input output pins are working, how to configure output pins, how to write embedded C code, how to program compilation works, how simulation software execute the program. I used PICSimLab to simulate the hardware. After compiling the program, I observed the LED blinking continuously in real time. This experiment helped me understand how to complete embedded software development process. I will show you. First, we open the STM32 Cube IDE software. ये थोड़ा टाइम लेगा. यहाँ से लॉन्च करेंगे. First, go to the file, new. In file, go to the new, then STM32, new file, new file, STM32 project. Now go to the MCU MPU selector. In this, select STM32 C010. Let me check once. STM32 F103 C8 T6, ये वाला। इसके बाद हम ये फर्स्ट ऑप्शन सिलेक्ट करेंगे कंट्रोलर का। नेक्स्ट, यहाँ पर हम प्रोजेक्ट का नाम देते हैं। पहले since we are going to blink the LED, so give project name as a LED. Finish. इसके बाद yes, band close. Wait until it opens. Okay, इसके बाद finish. Now go to the clock configuration, check all things. For LED blinking, it remains same. So go to the pin output configuration. In this, we are taking pin number 13 as the output. So select GPIO output. Save it. And do you want to generate code? यहाँ पर स्लाइड आएगा, इसको यस करेंगे। इसके बाद देखेंगे सॉरी, पहले वो नहीं था। अब इसको लेंगे और द आउटपुट पिन, और यहाँ पर देखेंगे, यस करके सेव कर लेंगे। इसके बाद जाएंगे हम कोर पे, और यहाँ पर देखेंगे SRC में हमारी main.c फाइल दिख रही है। सो यहाँ पर कोड आ गया हमारा। इन दिस इज main.h, मेन कोड है ये। अब हमारा जो कोड है ब्लिंक करने का, वो यहाँ पर लिखेंगे हम while 1 में। इसको नेम दे देते थे LED ब्लिंकिंग। कोड है हमारा GPIO toggle pin GPIO पिन 13। यहाँ पर 13 लिया है क्योंकि हमारा जो आउटपुट पिन है वो हमने 13 लिया है, C13। इसके बाद ये चेयर डिले डिले आएगा हमारा 500 मिली सेकंड है वो। हम यहाँ पर 1000 भी लिख सकते हैं, तो हमारे पर डिपेंड है। इसको कर लेंगे सेव। ये हो गया हमारा कोड। इसके बाद हम उसको बिल्ड करेंगे, इसलिए प्रोजेक्ट पे राइट क्लिक करके बिल्ड प्रोजेक्ट, राइट क्लिक करके बिल्ड प्रोजेक्ट करेंगे। सी 0 errors. So again right click on the project, go to the properties, build, इस पे जाएंगे हम, then go to the settings, MCU MPU post build outputs, convert to binary file, इसको क्लिक करेंगे हम, then apply। so हमारी बाइनरी फाइल तैयार हो गई है। इसके बाद ये मिनिमाइज करेंगे और हमारा PICSimLab जो है वो ओपन करेंगे। इसमें फर्स्ट कोड सिलेक्ट करना है, कोड एज ए ब्लू पिल। देन हमारे जो फ्रीक्वेंसी है वो 8 ही रखेंगे, CMU MIP PSVP 31.25। देन गो टू द फाइल, लोड बाइनरी फाइल, सी बाइनरी फाइल लोड हो गई है। सी हियर द टॉगल, LED टॉगल हो रहा है, blinks। In this way we are complete our first project। So next move to the ADC core. This slide explains the analog to digital converter, commonly called ADC. Many sensors produce analog voltage. However, microcontrollers can only understand digital values. The ADC converts analog signals into digital numbers. For example, if temperature sensor gives a voltage of 2 volts, the ADC converts it into a digital value that the microcontroller can process. During the internship, I learned ADC working principle, analog to digital conversion, reading sensor values, converting ADC values into percentage. These concepts are very useful in electric vehicles because battery, voltage, temperature, current, and accelerator position are all measured using ADC. Without ADC, the microcontroller cannot understand real-world analog signals. Another project was we learned about the ultrasonic sensor. This slide explains the HCSR04 ultrasonic sensor. An ultrasonic sensor is used to measure distance. It works using ultrasonic sound waves. The sensor has two main parts, trigger and echo. When trigger pin receives a pulse, the sensor sends an ultrasonic wave. These waves hit an object and return back. The echo pin measures the time taken for the wave to return. Using this time, the microcontroller calculates the distance. During the internship, I interfaced the ultrasonic sensor with STM32. I learned how to measure the distance between the sensor and obstacle. This sensor is widely used in parking assistance, obstacle detection, robot navigation, automatic braking system. It is one of the important sensors in ADAS. So next is EV concept learn. This slide explains the electric vehicle concepts. An electric vehicle runs using electricity instead of petrol or diesel. The major components of EV include battery, electric motor, motor controller, battery management system, charger. The battery stores electrical energy. The controller manages the motor. The electric motor converts electrical energy into mechanical energy to move the vehicle. One important concept is static of charge or SOC. SOC indicates how much battery charge is remaining. For example, if the battery is fully charged, so the SOC is 100%. If half of the battery is remaining, the SOC is 50%. Embedded system continuously monitor battery voltage, current, and temperature to calculate the SOC. These embedded systems improve battery life, vehicle safety, and overall performance. So next is ADAS overview. This slide explains advanced driver assistance systems, commonly known as ADAS. ADAS is a collection of intelligent safety technologies that help drivers avoid accidents. It uses camera, sensor, ultrasonic sensor, radar, and microcontrollers. Some important ADAS features are obstacle detection, parking assistance, lane keeping assistance, adaptive cruise control, automatic emergency braking, blind spot detection. During the internship, I understood how ultrasonic sensor help detect nearby obstacle during the parking. ADAS improves road safety by reducing human errors. Today, ADAS technology is widely used in modern electric and autonomous vehicles. It provides better comfort, safety, and driving assistance. So, finally, I would like to conclude my presentation. This internship helped me gain practical knowledge of embedded system, STM32 programming sensors, ADC, electric vehicles, and ADAS. I improved my programming skills and understood how embedded systems are applied in real automotive applications. This internship has increased my confidence and prepared me for future projects and career opportunities in embedded systems and the automotive industry. Thank you for your valuable time. I hope you found my presentation informative. Thank you once again.